Look at this, guys. So what we have here is we have a circle with an 80 millimeter diameter. We have two tangents coming off that circle to a 200 millimeter segment down here. And that segment is centered. It may not look like it, but it is centered. So, and it is tangent, both of them. All three of them are tangent. So what that means is from this point over is exactly half of the 200. That's 100 millimeters on each side. What I'm going to ask you to find here is to find the area. Yeah, actually, I want you guys to try this for about 5 minutes or so. See how far you get with it, and I'll check with you, see if you've got any questions. Just a progress check here. So, if I go from the center of the circle, I'm going to create 3 radii. 1 to there, 1 to there, and 1 to there. So I know this creates right angles on both sides, right angles here and here. How long are my radii? 40 millimeters, 40 millimeters, and 40 millimeters. This is 100 here and here. What's this one? 100. Because remember, tangents that intersect have to be the same length. What'd you do from there? I'll give you a hint. That would be my next step. Now we need angles. You are correct. What angle do we need to find? This one right here is the one we're looking for. Actually, all of these are going to be the same, right? These are all the same triangle. They're all 40 by 100s. This is 40 and 100, and this is the angle we're looking for. And yeah, we have the opposite side is the 100, and the adjacent side is the 40, so that's going to be the tangent. So then the tangent of that angle, opposite side's 100, adjacent is 40. So the angle will be the inverse tangent of 100 over 40. So second tangent, 100 divided by 40. 68.20 degrees. Now again, we have 1, 2, 3, 4 of them around the circle. So I'm going to multiply by 4. So 272.79. Notice I multiplied the unrounded number, so I got a little bit more exact. So that means that all the way around here is the 272.79. Well, those angles are parts of the triangle. I really don't need those angles. The angle I really need is this one right here. That's going to be found by doing what? 360 minus the 272.79. 87.21 degrees. And now we have everything we need for this area. Because we've got parts 1, 2, 3, and 4 that are identical. 1 through 4 are all triangles that are 100 by 40, of course divided by 2, which is going to be 2,000 each, millimeters squared. But there's 4 of them, so times 4 makes 8,000 millimeters squared. And then we've got that sector of a circle up here. And that sector, which I'll call section 5, is going to be found by finding the area of the whole circle. That's going to be pi times 40 squared times that angle of 87.21 over 360. So we get 1217.06. So that gives us 9,217.06 millimeters squared. Here's our area of that. Anybody come close to that? Anybody just run out of time but was heading in the right direction? Any questions on how I got that or why I did any of the things I did there? This strategy here, by the way, should look familiar. Of taking that and dividing up, because that's the exact same strategy we used when we had a part in a V block. Oops. You know, we drew in the radii to those tangents, and then we cut it down the middle to split that triangle into two equal triangles. So that's a very common strategy that we'll use. For what? For what? 9,216.9? Yeah, that'd be okay. Usually on one of these, I'd give you a plus or minus 5 or 10 millimeters squared, depending on the problem. This one probably only 4 or 5, because there's only really the one area that has pi in it. The 4 triangles should be able to get pretty exact at the 8,000. So the only round off would be in this part. But yeah, you're within a millimeter squared, you're okay. So let's look at some variations of this. I'm going to cheat here just because. Yeah, there'll be a worksheet with problems like these on them. So what we have here, 3 circles, all with a diameter of 50 millimeters. All connected with tangents. The circles are all tangent to each other, by the way, at these points. Find the area. I'll give you guys a few minutes to break those down. Need a hint? Okay. Well, again, we have tangents. So that means we're going to start out the center of each circle. We're drawing radii. And they are going to make right angles with our tangents. Now what I'm going to do is I'm also going to connect the centers of those circles, like that. So what this is giving me here is 3 rectangles. And this rectangle is 25 millimeters this direction. That's just the radius of a circle. What is it this direction across here? 50. Because this is just 2 radii here. So I've got, I'll call it 1, 2, and 3 are all rectangles. They're just 25 by 50, and then times 3 because there's 3 of them. So it's at 1250 times 3 is 3750 millimeters squared. The triangle in the middle is 50 millimeters on each side. It's equilateral. So there's 2 ways I can handle it. I could use my hero's formula. Remember hero's formula? You have the perimeter of a triangle. You know all 3 sides. You can find the area. Or, since we're talking about trig, let's use trig. We can cut it like that. So what I have done is I've cut it into a triangle that looks like that. This is 25 here. This hypotenuse is 50. I need to know this side here, which is going to be a squared plus b squared equals c squared. So 50 squared minus 25 squared, square root. Giving us 43.30. So this triangle, the full distance across here is 50. So for that triangle, the area is going to be 50 times 43.30, then divided by 2 because it is a triangle. So 43.30 times 50 divided by 2. 1082.53. Well, because I took the whole distance across here is 50 instead of 25. This purple line? Because I had to find that height. So I cut it in half first to make this triangle over here. So then I had the 50 and the 25 to get that height. Now that I have that altitude, then I can go back to the whole 50 for the base. And now the part that most people think they're going to have to use trig for, they don't. These angles here. First of all, what is that angle? Well, this is 90 degrees, this is 90 degrees. What's this angle here have to be? 60, because it's an equilateral triangle. 90, 90, and 60 makes that 120. So I could find that angle that way if I wanted to. Also, I know that this arc, and this arc have to come together to make what? If I move them out of there to make a full circle, to put them together, they make a full circle. Yes, they do. 360. If I draw my circles well, they would at least. So that's just a complete circle. So that's part 5, 6, and 7 is just a complete circle. Pi times 25 squared. So 1962.5. That's just the area of the whole circle. That's these 3 third circles coming together. That's the equilateral triangle, yeah. If all 3 sides are the same, then all 3 angles have to be the same. Let me come back to that question in just a second. Oops, helps if I add correctly here. So 6,795.03 millimeters squared is my area. So the question is asked, would it have been any easier to extend outside the circles and subtract the circles? That's a very good question. Let's try it. Because that's one thing about these problems is you don't always look at them and know the best way to do it. Sometimes you just have to try it and see if it works out, and if it doesn't, you try something different. So if we were to have extended these and found the area of the big triangle, well, first we know the distance from here to here is 50, right? So that's 50 on all sides. What we don't know is the distance from here to here yet. So let's work on that up on this triangle, in this circle here. We know this is 25 and this is 25. And we know this angle here is 60 degrees. How do I know that's 60 degrees? Equilateral triangle. If I cut this down the middle, this will be 30. So then I'm going to deal with this triangle over here. I'm going to lay it this way. This is 30 degrees. This is my right angle. That's the right angle right there. This is 25. I'm looking for this down here, which is going to be 43 point something. 43.30. How do I get 43.30 there? Well, this is the opposite side. This is the adjacent side that I'm looking for. So that's going to be a tangent. So tangent to 30 degrees equals 25 over that adjacent side. Put this over 1 times 25 divided by tangent of 30. 43.30. So we've got that down. What's next? Okay, well, let's what we could do here is we would have, obviously the whole side here is what, 86.6, 136.6 millimeters is the whole side of each of this triangle here. So we could use that to find the area of the big triangle. So I'm confident we can find the area of the big triangle. The question now really is can we find the area of these pieces to subtract out? And to do that, it's going to be a little more indirect. I can find the area of these triangles to find the area of this whole corner here. So the area of this triangle right here is going to be 25 times 43.3 divided by 2. There's 2 of them, so I would multiply that by 2 then as well. Does that make sense? So 43 times 25, and I'm not going to bother dividing by 2 because we're going to multiply by 2. 43.3 times 25. Yep, like I said, I know we can find the area of the whole triangle, so I'm not worried about that part. I want to look at these corners now. So that's the area of this whole corner here. To get just this red piece out here, I'd have to subtract out this sector. And I know that that sector has an angle here of 120 degrees. Because this is 30, this has to be 60, so the whole thing has to be 120. So that is a sector of 120 degrees. So we're going to do the area of the whole circle is pi times 25 squared times 120 over 360. So 3.14 times 25 squared times 120 over 360. 654.17. So that's the sector here. So we subtract those to get that piece that's out there in the corner. So 1082.5 minus 654.17. So 428.33 millimeters squared. So you'd have to subtract that out 3 times. Yeah, that would work. So you see, yeah, it would be solved. It would be solved that way. I think it's maybe just a touch more difficult this way, but not much. Okay. I'm going to give you a worksheet to work on. And then, let's see, this is Thursday, so I won't see you again until Monday. It looks like probably around Wednesday or Thursday of next week, we'll be looking at a test, or not a test, but a major quiz. This won't be a unit test. This is kind of like a little sub-unit before we move on. The biggest thing I want you to start getting out of these problems, because on Monday what I'm going to do is I'm going to give you a worksheet. It's not going to be a quiz or anything. It'll be homework. But I'm going to give you a worksheet with problems related to these, where it's, circles with tangents, but in slightly different contexts. And I want to see if you can break down those problems. I mean, the sign that you truly understand math is not that you can solve a problem that looks just like the ones we've done on the board with different numbers. That just means you can follow a process and apply that same process. The sign that you truly understand math is you can take a problem that's slightly different, not just different numbers, but a slightly different layout, and figure out how to apply those same concepts to solve it. So that's what we're trying to shoot for here in the next week, is giving you those problems that are not problems we've done before, but they use the same concepts that we've used before. All right, so I'm going to hand that worksheet out for you. Well, English they usually get more than a shot later. Right?
Are these getting turned in like this one?
No, this is just one. Sure.
I got a boys like that. Any more information?
Nope, we're done. Have a good one. Price quiz time.
He just walked off.
Oh, I see.
See one more time.